In part one of the video presentation entitled What is TCCS, we studied the diagnostic function of TCCS. The diagnostic function, however, is limited in that it does not indicate what part of a signal system is malfunctioning. Furthermore, problems in some systems cannot be detected by the diagnostic function of the TCCS. Whether a trouble code is indicated or not, therefore, it is necessary for you to carefully check signal systems when it appears that there is a TCCS problem. In part two of this video presentation on the TCCS, we will talk about system inspection, which helps you perform efficient checking of the signal or sensor circuitry. But before we start a system inspection of the TCCS, we must first check the items shown in the diagnosis manuals, because they can affect the operation of the engine even if the car is equipped with TCCS. This preliminary check is called basic engine inspection. For the purpose of this presentation, we will talk about system inspection of some of the main signal systems in TCCS using the 4AGE engine mounted on the 1986 Celica as an example. But the system inspection which we are about to study applies basically to any other model of engine as well. We will divide system inspection into two volumes, Volume 1 and Volume 2. In Volume 1, we will show how to inspect the diagnostic system, fuel system, injectors and their circuitry, and the cold start injector and its circuitry. Problems in these systems cannot be detected by the diagnostic function. In Volume 2, we will study the throttle position signal circuitry and idle signal circuitry and a number of other items as you see here. One word of caution before we begin. When we check the TCCS, it is very important to follow these precautions, which are found in repair manuals and diagnosis manuals. Let's begin by inspecting the diagnostic system. First, we must determine if the diagnostic system is functioning normally or not. To do so, we turn the ignition switch to on and see if the check engine warning lamp lights up. Then we start the engine and see if the check engine lamp goes off. Next, with the ignition switch on and the throttle valve fully closed, we short terminals T and E1 of the check connector and see if a diagnostic code is indicated. If any of the diagnostic codes is indicated, you can conclude that the diagnostic system is functioning normally. You can understand the diagnostic system inspection more clearly by looking at this circuit diagram. When the ignition switch is turned on, the EFI main relay goes on and battery voltage is applied to the plus B and plus B1 terminals of the ECU. A transistor in ECU therefore goes on, and terminal W is grounded via E1 terminal. The check engine warning lamp lights up as a result. If the warning lamp did not light up when we turn the ignition switch on, we check the fuses, the check engine lamp bulb, the EFI main relay, the ECU, and all related wiring. Assuming that the check engine warning lamp did not turn on, let's start by checking the fuses first. The fuses used for the TCCS circuitry may have different names depending on the vehicle model, so you might have to identify them by looking at the repair manual or wiring manual. If the fuses are in good condition, the next step is to check the check engine lamp bulb. The bulb may be checked by directly grounding terminal W of the ECU. If the check engine warning lamp does not light up when terminal W is grounded, the bulb may be blown out and have to be changed. Let's see how to ground terminal W. If the warning lamp does light up in this test, what shall we check next? Yes, the next thing we need to check is the circuitry of the ECU's power supply. First, we check the EFI main relay. Remove the relay and measure the resistance between terminals 1 and 2 to see if the coil is intact. If this is okay, connect the battery to terminals 1 and 2 and measure the resistance between terminals 3 and 4 to see if the contacts have closed. If no problems are found, the EFI main relay can be reinstalled. Now, measure the voltage between terminals plus B or plus B1 and terminal E1 of the ECU. If the measured voltage is equal to the battery voltage, there may be a problem in the grounding of terminal W of the ECU. If the battery voltage is not being applied to terminals plus B and plus B1 of the ECU, there may be a problem in one or more of these areas. In some cases, the check engine warning lamp will not go off, even after the engine has started. Normally, when the engine is started, NE signals from the distributor are input into the ECU, causing the transistor to turn off. This, in turn, stops the current from flowing to the warning lamp, so the check engine warning lamp goes off. But if the diagnostic function detects a malfunction in a signal system, the check engine lamp will light up even while the engine is running to warn the driver. For this reason, if the check engine lamp lights up while the engine is operating, first short the T and E1 terminals of the check connector like this. And see whether a diagnostic code is displayed. If the check engine lamp lights up but no diagnostic code is displayed, It may be because the wire harness is grounded somewhere between the check engine lamp and terminal W of the ECU. Or it may be that the transistor is not going off as it should. In other cases, a diagnostic code may not be indicated at all when T-terminal is shorted. This sometimes happens when there is an open in the wire harness for terminal T or E1. Finally, we need to check the backup power supply of the diagnostic system's memory. This memory allows the ECU to store trouble codes even when the ignition switch is turned off. The check should be done by measuring the voltage between terminal BATT of the ECU and the body ground. If no voltage can be found, we should check the fuse. Our next subject is inspection of the fuel system. Fuel system inspection begins with the fuel pressure check, as this determines whether the fuel system as a whole is functioning normally or not. In this volume, we will talk about problems in the system that cannot be detected by the diagnostic function. So, let's see how this check is made. First, of course, we check to see if the fuel tank is full. Then, we install a fuel pressure gauge in accordance with instructions in the repair manual. There are 4 items that should be checked using the pressure gauge. First, we check the fuel pressure while the engine is cranking. The normal range is shown on the gauge in green. Then, we check the pressure when the engine is idling. Now, we check the pressure when we suddenly open the throttle valve all the way. Finally, we stop the engine, wait for at least 5 minutes, and measure the residual fuel pressure. If the pressure gauge reading is within the normal range during all 4 of these pressure checks, you can conclude that the fuel system is in good condition. If a reading differs from normal values, we must check further. But before we do this, let's see how the electrical circuitry of the fuel pump operates. When the engine cranks, electric current flows from terminal ST of the ignition switch to coil L2 of the circuit opening relay and then to ground. Therefore, the relay turns on. At the same time, current flows to the coil of the EFI main relay, causing the relay to turn on and current to flow to the fuel pump via the circuit opening relay. The fuel pump, therefore, begins operating. Immediately after engine cranking, the distributor sends an engine speed signal called an NE signal to the ECU. The FC terminal of the ECU is grounded as a result, and current flows to coil L1 of the circuit opening relay. Therefore, the circuit opening relay remains on while the engine is running, even after terminal ST of the ignition switch goes off, so the fuel pump continues to operate. Now, if the fuel pressure remains at 0 during engine cranking, we should check to see if the fuel pump is working normally by shorting terminals plus B and FP of the check connector. In the case of a multi-pin type connector, we bypass the circuit opening relay like this, and with the ignition switch in the on position, apply electric current directly to the fuel pump. This is what the fuel pump sounds like when it operates, and the fuel pressure will rise to the standard value. This sound tells us that the fuel pump functions when we bypass the circuit opening relay, which indicates that there is no problem in this circuit. Therefore, we must check the circuit opening relay circuit and this circuit also. So, let's check the circuit opening relay and its power supply. First, remove the relay from the circuit. Then, measure the voltage between terminal plus B of the relay connector and body ground. Let's see how to check the power supply. If the measured voltage is equal to the battery voltage, check the circuit opening relay itself. With the battery connected up to the STA and E1 terminals, measure the resistance between terminals plus B and FP of the relay to see whether or not the relay contacts have closed. If there is no continuity between plus B and FP, there may be poor contact between the points. Or there may be an open in coil L2. If the ohm meter reads 0, we can conclude that the circuit opening relay is okay. So, crank the engine to measure the voltage between terminal STA of the relay connector and body ground. If the standard voltage is not being applied, there may be an open in the wire harness between these 2 points. If the measured voltage is equal to the standard voltage, there may be an open in the wiring between the relay and the fuel pump. If the relay is okay, reinstall it and check this circuit next. To see if the standard voltage is present at terminal FC of the ECU with the ignition switch in the on position. If there is no voltage, there may be poor contact in terminals plus B or FC of the relay. Or there may be an open in coil L1 or an open in the wire harness. If the standard voltage is being applied, crank the engine and see if the voltage at terminal FC of the ECU drops. If the voltage does drop below 1 volt, the trouble may be due to poor contact at terminal FP of the relay. Now, let's crank the engine and see if the voltage drops below 1 volt. Here, the voltage does not fall to below 1 volt. This could occur for a number of reasons. For example, terminal E1 of the ECU may not be grounded properly. Or the ECU itself could be at fault. The next test is to short terminals plus B and FP of the check connector like this. But we can't hear the fuel pump operating, can we? Since the fuel pump does not operate when we bypass the circuit opening relay, the fuel pump itself may be out of order. Or there may be a problem in the power supply circuitry. So, we check the voltage between the terminals of the fuel pump connector to see if it is equal to the standard voltage. If it is, this means that voltage is being applied to the pump. So we can conclude that there is a problem in the fuel pump itself. Now, let's see how to actually check it. If the voltage at the fuel pump connector is 0, there may be a problem in either the fuse, the EFI main relay, or the fuel pump grounding circuit. If this is the case, you must check each of them separately. There are also other types of problems, like this one. Sometimes the fuel pressure falls slowly after the engine has started. What could be the cause of this? Since the fuel pressure is normal during engine cranking, the circuitry of coil L2 is probably normal. So we can conclude that the problem may be caused by a defect in the circuitry of coil L1 in the ECU or in the wiring between them. We have already studied how this circuit can be checked. The next problem, which we will look at, is the problem of the fuel pressure being too high or too low during idling or racing. We will first explain, using this demonstration model, the case of high fuel pressure. Fuel pressure can rise too high if the fuel return line is clogged or if the pressure regulator is malfunctioning. If the fuel return line becomes clogged, the fuel pressure in the high-pressure line will increase. If the fuel pressure tends to remain too high during engine idling, the pressure regulator must be inspected. Now, let's inspect the pressure regulator. With the engine idling, remove the vacuum sensing hose from the pressure regulator. Then, see if the fuel pressure is within the specified range, both when the hose is fitted and when it is removed. Let's assume next that the fuel pressure is too low during racing. If fuel pressure is too low during racing, the first thing to do is check the fuel filter for clogging. If the fuel filter is not clogged, what should we do next? First, pinch the fuel return hose, and then crank or start the engine. If the fuel pressure is higher than the specified level when you do this, it may be that the fuel pressure regulator is at fault. If the fuel pressure is lower than the specified level, however, you might conclude that the fuel pump is at fault. Now, the fourth item is the residual fuel pressure. If you check it and find that the pressure is lower than normal, this may be a result of any of three problems. It may be because the check valve built into the fuel pump is defective. It may be due to a faulty pressure regulator. Or it may be a result of the injector sealing trouble. Now, we'll see how the injectors and their circuitry are inspected. We can tell whether or not the injectors are operating normally by listening to their sound using an instrument called a sound scope. If you can hear a regular rhythmic sound like this, you can tell the injectors are working normally. If any of the injectors is malfunctioning, it could cause an idling problem or lack of power. Let's study this in more detail using a circuit diagram showing how the injectors are connected. If you can hear the sound of at least one injector operating, you can conclude that the power supply circuitry itself is in good condition. If some of the injectors are not operating, you should check their connector contacts or look for open circuits in their coils. We will see how injectors are inspected for open circuits. If an injector does not operate and you do not find any opens in the injector coil, the injector valve may be stuck. Now, if you do not hear any operating sound at all from all of the injectors, you should check the voltage between one of the injectors and the body grounding. If the measured voltage is not equal to the battery voltage, you should check the fuse. Let's check the voltage of the injector connector first. If there is voltage between the injector and body ground, check the voltage at terminal BF of the ECU. Then, measure the voltage between ECU terminal number 10 or number 20 and E01 or E02 to check the ECU grounding circuit voltage. If the measured voltage is equal to the battery voltage, you will probably have to replace the ECU with a new one. Now, let's actually check it. This shows how to check the ECU's BF terminal voltage. And this shows how to check the ECU grounding circuit voltage. Next, let's check the injection volume and valve seating. Even if you can hear the rhythmic sound of the injectors operating, you may still encounter a lack of power or poor idling if the injection volume is not correct. Before checking the injection volume, you must disconnect the negative terminal from the battery. Then, remove the injectors. Now, using a special service tool, connect the fuel filter, pressure regulator, and an injector like this. When all connections are ready, turn the ignition switch on and then short terminals plus B and FP of the check connector. Then connect the test probes of the SST to the injector. Be sure to use the correct inspection wiring since it differs depending on the type of the injector or its circuitry. Next, connect the inspection wiring to the battery like this. Measure the amount of fuel injected for a period of 15 seconds. During this time, you must place the injector as far as possible from the battery. And see if the specified amount of fuel is being supplied. Then check the amount of fuel leaking from the valve of the injector. The valve is seated correctly if no more than 1 drop of fuel leaks out within a minute. Next, let's check the cold start injector time switch and cold start injector. This is the cold start injector time switch. And this is a cutaway model of it. Let's compare the circuit diagram with the cutaway model. This is a bimetal switch. The contacts are closed while the engine is cold. When the ignition switch is turned to start, electric current flows through this circuit and the cold start injector is actuated. At the same time, current also flows to these 2 coils and warms the bimetal switch. When the bimetal switch has heated up enough, the contacts open and prevent electric current from flowing to the cold start injector. This means that the cold start injector is not actuated while the engine is warmed up since the bimetal switch is open. Let's begin the inspection now. We will start with the cold start injector time switch. First, we check the resistance between terminal STA and ground. Then we check the resistance between terminals STA and STJ twice. once when the coolant temperature is below 35 degrees centigrade, and again when the coolant temperature is above 35 degrees. This shows how to check the resistance between STA and ground. And this shows how to check the resistance between STA and STJ. If the bimetal switch remains open when the engine is cold, the cold start injector will not be actuated and the engine will not start easily. On the other hand, if the bimetal switch remains closed even after the coolant warms up, an overly rich air-fuel mixture will be sent to the cylinders. This will also cause hard starting. Next, let's check the cold start injector. First, we measure the resistance to determine whether or not there is an open in the cold start injector. Then we check to see if the cold start injector is injecting fuel or not, and to see if there is any fuel leakage from the cold start injector, as we checked injectors before. In this video presentation, we have studied system inspection methods for the diagnostic system, fuel system, injectors and their circuitry, and the cold start injector and its circuitry. In Volume 2 of this presentation, we will study other subjects, such as these shown here.